9.1a, graphing exponential functions. So we're going to look at exponential functions, domain and range, and asymptotes. So we touched on exponential functions a little bit in Algebra 1, but we have two types of exponential functions. We have exponential growth or exponential decay. So when something is growing exponentially, that's like bacteria. Bacteria doubles every second, or whatever the type of bacteria is growing. It means that you can start with one, and very short amount of time, it grows exponentially. So the graph looks like this because it starts out very small, and then in a short amount of time, it grows and it continues to get exponentially larger. And in exponential decay, it's the reverse. It starts high and then decreases very, very fast. Decreases fast. An example of exponential decay is like the value on your car. Unfortunately, your car loses value very, very fast. So the minute that you drive it off the lot, the value decays, and it actually decays exponentially from there. So used cars don't hold their value very well. This is the equation for like a general exponential function. The A tells us if it's a vertical shrink or stretch to the function. Basically, that controls whether or not it is rising or dropping faster or slower. So the A value is responsible for that. It also is a reflection over the x-axis if it's negative. So we could say, or a reflection when it's negative. The B value in the middle here, that tells you if it's going to be exponential growth or decay. If B is greater than 1, so you have a whole number in there like 1, 2, 3, 4, 5, then your function will be growth. If the B value, so the number that's being raised to the power, is less than 1, so you have a fraction like 1/2 or 1/3 to the x, this then is exponential decay. And H and K that you see up in that equation are the horizontal and vertical shifts. The H is going to shift it left and right, and the K is going to shift it up and down. So the K is like the starting point, kind of like a y-intercept, but shifts it up and down. The H value shifts it left or right. And then they also have asymptotes. So it's an imaginary line that the graph doesn't cross. This function here, like exponential growth, is going to continue to get exponentially larger, but it's never going to cross this 0 down here. So this is an asymptote. Same with here. It's going to keep getting smaller and smaller and smaller, but it's never going to cross 0, or it's never going to get below 0. It's like an exponential growth starts out small but gets bigger, approaches 0. All right, let's look at a few examples. We're going to use the parent function idea to graph it. This is similar to a parent function of exponential growth. Parent function for exponential growth would be like y equals b to the x. So you don't have an a value, you don't have a shift. And this is 2 to the x power. So we're just going to graph this with a standard xy table. And we're going to pick the values for the table. We're going to pick -2, -1, 0, 1, 2. And these are going to be the values that I pick every time. And for the function then, your function is 2 to the x power. So I'm going to take 2 to the x power, where these are my x's in the left here. So 2 to the -2 power, remember that's the same thing as 1 over 2 squared. So that's going to give me 1/4. 2 to the -1 power, using my exponent rules, that's going to be 2 to the 1 over 2 to the first, or 1/2. 2 to the 0 power, anything to the 0 power is 1. Oops, I said 1/2, but I wrote 1/4 there. 2 to the first power is 2, and 2 squared is 4. This third column is reserved for my AY. If I had an A value, in this case, A is equal to 1, so none of that changes. It's not been vertically stretched. It's rising at the standard rate, except for our base is 2. So it is exponential growth, which means the base of 2 means that it's like doubling every time. So it is growth. We have a base B is equal to 2, our growth factor of 2. We have a HK of 0, 0. There is no shift. We'll get to domain and range in a second. Let's graph it, and then you should be able to see the domain, range, and asymptotes. So I'm just going to graph these ordered pairs. So negative 2, 1/4. I'm going to go to the left, negative 2, and up 1/4. Is up a little high, but do my best on the computer here. Then over negative 1, up 1/2. Oops, I'm off. We got to zoom in real good. And then 0, 1, over 2, or over 1 up 2, over 2 up 4. So I did the best I could there. And then it's going to continue to get lower, and then it's going to rise exponentially. I can zoom out. Now the asymptote is going to be the line that it's approaching down here, and it's actually going to approach 0. And that asymptote corresponds to my K value. So I have an asymptote at Y equals K. In this case, then it's Y equals 0. So it will approach this x-axis but never cross. And then remember, domain are x values. So if you think about on the x-axis here, you could plug in any x that you want. You could take 2 to the negative 10th power or 2 to the positive 10th power. Either way, you'll always get an output. So domain is going to be all real numbers, or x is going to be an element of the real numbers. Now range is the y values. And if you look at the output, the purple function here, all of your output functions are above 0. So your range is going to be all your y values that are greater than, actually not equal to, because it will never equal 0, just greater than 0. So it corresponds to your asymptote, and your range kind of go together here. If the function is above the x-axis, it's greater than that asymptote. If it's below it, then it's less than that asymptote. All right. I'm going to skip that one for now. I'm going to do one with a shift. Okay, so this one has, let's see. We'll do this one. Okay, so remember our original function is y equals a b to the x power x minus h and then plus k. So if I identify my pieces here, the b value is 1/3 here. So that means that it's going to be decay because I have a b value that's less than 1. Now I have an a value of 2, so in my third column, whatever I get, it's going to be 2 times that middle column, 2 times f of x. Now my hk values, that's here, h and k, I have an h, I have nothing for k. Now it's x minus h, so h is going to be opposite, so my shift will be 3, and then there's no k, so 0. So I'm going to have a shift hk of 3, 0. So my shift is going to be 3, 0. So that means I'm going to shift this entire graph to the right 3 and up 0. And I'm going to treat that 3, 0 point, this point right here, as my new origin. So this is going to be my new origin. 0, 0 there. Okay, so I have my shift and I have that it's decay. Now I'm going to graph, I'm going to pick the points -2, -1, 0, 1, 2 again. But this time my f of x, my b, this is b to the x, it's 1/3. So I need to use 1/3 to the x power when I plug in these x values. In the last example, our b was 2, so I plugged in 2 to the x. Now our b is 1/3, so I'm using 1/3 to the power. So if I have 1/3 to the power of -2, that's really like 3 over 1 to the positive 2 power, which 3 squared is 9. So remember the negative exponent rule? You take the reciprocal. So 1/3 to the -1, that's going to be 3 to the positive 1, which is going to be 3. 1/3 to the 0 power, anything to the 0 power is just equal to 1. 1/3 to the first is 1/3 times 1/3, so 1/3. And 1/3 squared is going to be 1/3 times 1/3, which is going to be 1/9, or square the 1, square the 3. This time we do have an a value of 2. So now we have to take everything in the middle column and times it by 2, which means this is a decaying function, and then it's decaying even faster because it has a value of 2 out front. So 9 times 2 is 18. 3 times 2 is 6. 1 times 2 is 2. 1/3 times 2, I do 1 over 3 times 2 over 1, and I get 2/3. 1/9 times 2, I'm doing 1 over 9 times 2 over 1, and I get 2/9. Now I'm going to graph the first and last column, so maybe I want to cross out the middle one. And I'm going to graph the over -2 up 18 from your new origin. So make sure that you're starting right here at this 3, 0 part. And you're going to go to the left 2 up 18 is going to be way off my graph, so that one doesn't fit. So I'm going to start with -1 up 6. And -1 up 6 then. 1, 2, 3, 4, 5, 6. So 18 is like way up here. 0, 2 is going to be right here. 1 2/3, it's going to be close to 1, and 2/9 is 0.2 repeating, so right about there. So it's going to start way up here, and then it's dropping very rapidly, but then it will slowly start to even out, and it's going to get really close to that 0 line, but it'll never cross it. So that y equals 0 again is my asymptote, because remember that k in this one was 0, so that's my horizontal asymptote as well. So my range will correspond to that as well. All my y values are going to be greater than or equal to 0. And now my domain, I can plug any x that I want, so my domain is going to be all real numbers again. In exponential functions, domain's all real numbers, and the y corresponds to the asymptote in the way that the graph opens, if it's above or below that. All right, I think I have one more example that I want to show in this video at least. This one has everything. So it has an h, it has a k, and it has a negative a value, so you'll see a reflection. Okay, so first thing, since it's a 1/3 again, we have decay instead of growth because it's less than 1. We have an a value, so it's going to be -2 times whatever we get in that third column. The x's I'm going to pick are going to be -2, -1, 0, 1, 2. The shift, that comes from my hk, so these two values. It's going to be the opposite of h, so -1, and the same for k, so -1, -3. So it's going to be shifted to the left 1 and down 3. So shift the whole graph to the left 1, and then we shift it down 3. Domain will be all real numbers. We can fill that in right now. And we'll have to, I want to wait for range because this one's reflected over the x-axis. So you'll have to wait to see what happens there and how that negative a affects the graph. But I do know that my asymptote corresponds with my k value, so my asymptote will be -3. It's going to get really close to this -3 value down here, but it's never going to cross it. So I use my b to the x, including here. So I'm going to use 1/3 again because that's my b. So I'm going to have 1/3 to the -2 power. Remember, that's going to reverse it, and it's going to be 3 to the second power, which is 9. 1/3 to the -1 will be 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. And 1/3 to the 2 is 1/9. Then I need to take everything in that middle column times -2, because that's my a value. So it'll be -18, -6, 2, negative 2/3, negative 2/9. And then I'm going to be graphing the first and last column from my new origin. So make sure that you're starting right here on that origin point right there. And then we go negative 2, negative 18 is going to be way off my graph again. So it's going to be way down here. Negative 2, negative 18. Negative 1, negative 6. 1, 2, 3, 4, 5, 6. It's right about there. 0, negative 2, 1, negative 2/3, and 2, negative 2/9. So hopefully you can see that it is going to get really close to this function. Oops, went too far over it. It's hard to draw with the stylus. It's going to get really close, but then it's never going to cross that. So this negative, it's actually kind of decaying from the other side. It's reflected. So it's coming in from the right and decaying to the left. Still exponential decay, just decaying from the other side. So my range then is going to be my y values that are associated with negative 3, but this time it's going to be less than negative 3. So less than negative 3. A couple things to remember is that for the table, I always pick the same x's, whatever these x's are, and I plug them into b to the x. So, oops. Let's go down. I think that's all the examples I'm going to do for this video because I'm trying to keep it a little shorter. But just a couple quick things. You have y, a, b to the x minus h plus k. So remember that hk, h is always opposite, and this is your shift. Okay? A is your last column in your table. And it is a vertical stretch or shrink. And it also is the reflection if it's negative. The table will always look the same in the values. You'll always pick the negative 2, negative 1, 0, 1, 2. And for your f of x column, you'll just do whatever your b is. So whatever's in the parentheses, or if there's not parentheses, that means there's no a value sometimes. So you'll do your b to that power. So whatever your b is to the negative 2, b to the negative 1, b to the 0, b to the first, b to the second. You will be expected to do those without a calculator. And then whatever your third column is you take it times your a value. So whatever times your a value is, so then it's a b to the negative 2, etc. And then you graph these first and last columns. So you graph the first and last column for graphing. All right, I try to keep it shorter. The rest of the notes will be posted on Schoology, and you can ask me for questions, of course. So hope